How much light do you have available in your greenhouses for growing crops? You may know what your crops need, but how much daylight actually enters the greenhouse? How much supplemental electric lighting do you need during the winter months? And how much will it cost to operate? Cerise365 and GreenHouseDesigner, or Cerise for short, can answer these questions. Cerise is a web-based software program that is designed expressly for luminaire manufacturers and greenhouse designers. Derived from world-class architectural lighting design software with a 25-year history, it brings power and reliability to horticultural lighting design. Cerise is easy to use. There is no software to install or worries about computer hardware requirements. All you need is a web browser on a desktop or laptop computer, a tablet, or even a smartphone. The design begins with the project information page, where the user enters the client and project information. Most commercial greenhouses can be grouped into one of 4 types according to their roof style: arch, Gothic, sawtooth, and Venlo. Similarly, polytunnels, hoops covered with polymer films, can be grouped into arch and Gothic designs. For fully enclosed vertical farms, there are 2 options: tables and stacked trays. For this video, we choose a Gothic greenhouse. Rather than requiring users to model greenhouses from scratch, the Greenhouse Designer component of Cerise automatically generates the selected greenhouse model within a fraction of a second. This is an interactive 3-dimensional model that the user can examine from any viewpoint. Depending on the greenhouse design, we can specify various building dimensions. Here we will simply change the number of bays, both length and width, from 2 to 4. And the new greenhouse geometry is generated almost instantly. The greenhouse glazing materials are now specified. We can specify the reflectance and transmittance of clear and translucent or frosted glazing for the roof and walls. We can also specify the reflectance of opaque materials for each wall. Here we will choose frosted roof panels. These could represent translucent glazing or sunshade fabrics. Next, we can specify the dimensions and spacing of optional tables or planting beds. We can also specify the expected plant canopy height. For this video, we have a choice of 9 horticultural lighting fixtures, or luminaires, from a fictitious luminaire manufacturer. And so we choose one at random. The luminaires are laid out with the specific row and column spacing and with the specified mounting height. We now need an array of PAR sensors to measure the photosynthetic photon flux density, or PPFD, at the height of the plant canopy. 3 measurement plane heights can be specified for plants at different stages of growth, but we will specify only one. For climate-based daylight calculations, it is important to know the latitude and longitude of the greenhouse in order to determine the nearest weather station. There are over 2,500 such stations worldwide, but Cerise will identify the closest one for any given location. We can now perform the electric lighting calculations. It will take only about 10 seconds for this 4,000 square foot greenhouse, but even a 1,000,000 square foot greenhouse is possible. And we are done. This visual image shows what the greenhouse lighting will look like at night. However, what we see is not as important as what the plants will perceive and respond to. And so we render the image again, showing the distribution of PPFD in monochrome and in pseudocolor to better understand the distribution. With the calculations completed, we can see a report summary for the project and generate a detailed report as a PDF file. Vertical farms are different from greenhouses, and so there is a different and somewhat simpler workflow. Returning to the basic design page, we choose a vertical farm with stacked trays. The only building dimensions are length, width, and height, so we change the height from 16 to 20 feet. Similarly, the only material properties are the wall, floor, and ceiling reflectances. The choice of luminaires is also different, as they will be fluorescent lamps or LED strips mounted to the bottom of each stacked tray. So we choose another luminaire at random and specify the tray dimensions, number of stacked trays, and spacing between the stacks. Cerise generates the trays for us automatically. The calculations again proceed quickly, and a visual rendering of the vertical farm is produced. More important, of course, is what the plants perceive in terms of PPFD. Again, with the calculations completed, a project report can be generated. Finally, we have daylight. Cerise can predict the amount of daylight available to crops within the greenhouse on an hourly basis throughout an entire year, using historical weather records. This means that users will be able to calculate maximum PPFD levels, daily light integrals, and projected operating costs for electric lighting on a monthly basis, as well as design motorized shade deployment schedules and more. Greenhouses are expensive to build and operate, and even more expensive when they do not perform as expected. How much daylight will be available throughout the year? How much supplemental lighting will be needed? How much will it cost to operate? Whether you're designing new facilities or planning for the next growing season, Cerise365 and GreenHouseDesigner has the answers.